Unreal Engine 5.7 is here and it finally fixes the fundamental issue that was stopping me from creating a truly customized MetaHuman with fully custom generated head and body sculpt without touching the third-party tools inside applications like Maya. You will still need a couple of lightweight tools along the way though, Blender for quick mesh conversion and Faceform for precise deformation. But the entire pipeline has become straightforward, fast and incredibly powerful. So in this video, I am covering the full process of creating a completely custom MetaHuman using AI generated head and body meshes. I will start by generating some concept art and then convert them into 3D meshes in applications like Meshy and Tripo. After that, I will bring the mesh into Faceform for accurate deformation and topology transfer. And finally, with this custom generated head and body meshes now perfectly matching the MetaHuman topology, I will create a fully custom MetaHuman character inside Unreal Engine 5.7. So let's get started. So here in Meshy, I generated some cool concept arts of the kind of head I want to create, and then I generated the actual heads from those concepts. You can already see how cool they look here with clean topology and solid textures. For today's demonstration, I want to create a female harpy, and this head model suits my use case perfectly, so I'm going to download this. Now let me talk a little about this extremely useful tool Faceform. Faceform is a free software with an intuitive node-based workflow to reshape one mesh into another while keeping the topology consistent. Along with that, it includes several very useful tools such as transferring texture maps and giving you sculpting controls to fine-tune your retopologized character. It is a free piece of software that you can download. I have placed the link in the description. And to get everything working the right way, I need two elements, the source geometry and the target geometry. For the source, I need the correct MetaHuman head topology. You will find that inside the MetaHuman Conform Topology plugin on the Fab Marketplace, the plugin provides the meshes only in FBX format and it includes both the head and body along with all the relevant texture sets. After downloading it, the first thing you must do is convert the head mesh into OBJ because Faceform unfortunately does not support FBX. Blender handles the conversion easily. Back in the Faceform in the graph panel over here, I added the loadgem node and import the source MetaHuman head mesh OBJ file. After that, I want the texture applied as well, so I bring in a load image node and import the corresponding color texture. Now I need to bring in the generated mesh as well. You can see that I am working in the viewport 3D tab here, where I can view the geometries in a proper perspective view. When I click on either of the loadgem nodes and press F, the viewport focuses on that particular character. At this stage, I actually need to align the two meshes because that makes the next steps much easier to handle. You can see that I can adjust the translation, rotation and scale to roughly align the target geometry with the source one. It does not need to be an exact match, and approximate alignment is perfectly fine. Next, I will add the select point pairs node and connect both the source and the target geometries into it. I am switching to the visual editor tab now, where the two meshes appear side by side. This part is going to be the most time consuming step in the entire workflow because I need to manually create as many point pairs as I prefer. Before I begin adding points, I want to set up the view. I adjust the camera angle for both split views so the two meshes are visible from the same perspective. And then I click sync view to lock the camera between the two panels. For simpler face meshes, you can skip this manual process entirely and go directly to the wrapping step. In that case, I would use the cartoon wrapping node, connect the source and target geometries and click compute. This wraps the source mesh onto the target mesh automatically. But as you can see here, this does not produce the accurate result we want for this character. Still, it is worth mentioning as an option if you ever want to try auto wrapping on simpler meshes. Leaving that aside, with the select point pairs node active, I will start clicking on each mesh to create the points. The ears of the target character is stylized and not your conventional ears, and we want the ears to be as accurate as possible. So I am going to place the points around the ears with extra care. These must be strict one-to-one matches. For every point you add on the source mesh, you need to add a corresponding point in the same general location on the target mesh. the placement does not need to be exact because the wrapping node does a great job of finding the correct regions during the computation. This is a very straightforward method. You do not need to be very precise, but you do need to make sure each point is roughly in the correct location. Once this is done, I connect the output of the select point pairs node to the third input of the cartoon wrapping node, and then I press compute. This uses all the point pairs for accurate wrapping. So depending on how many subdivision you added, the deformation will take a while to complete. So let's wait for that. Next, I add the brush tool. This node takes the output of the cartoon wrapping node along with the reference geometry and the source geometry as its inputs. The brush tool lets you adjust any deformation issues that might appear in your wrapped mesh. Remember to switch to the visual editor so you can clearly see the deformed mesh while you are making adjustments. There are several brushes that you can see over here, but the ones I find most useful are the relax and the inflate tools. They make the adjustment process quite easy and convenient for me. Once done, I will click on this accept button to accept the changes, and then I will right click on this brush node. Here you will get the option save geom, which is going to save this geometry as OBJ format. Next, I will use the transfer texture node to transfer the texture mapping from the target to the source. I'm switching to the viewport 2D tab so I can clearly see the changes on the texture map. The first input of the transfer texture node is going to be the reference geometry, and the second input is the output coming from the cartoon wrapping node. You can see that the modified texture aligns perfectly to the MetaHuman texture format. I will now add the extrapolate image node. This is going to fill in the outer edges of the texture map so you do not have any unwanted blank areas. Once everything looks good, I right click on the node and choose save output image to export the new texture. Now if you do not want those extra details in the texture, like the glowing markers or the electric lines, you can clean that up easily in Photoshop with generative fill. Removing or adding elements to an existing texture has become very simple and honestly quite fun. You can also notice some dark shadowy patches around the ear region, so I will clean those up as well. So this is the clean head texture that we can use. Let us move on to generating a body for our head. I am now using Tripo 3D to generate the body. It is always better to generate the body without a head because the MetaHuman body mesh you get from the MetaHuman Conform topology plugin is also headless. Keeping both meshes in the same structure avoids a lot of complications later. Or maybe not. Can we actually take a combined head and body mesh, deform it through Faceform, and then use that as a single piece to customize a MetaHuman? Technically, yes, it is most likely possible, at least for the body, if not for the head. There is room to experiment with it and see how far the system lets you go. I personally prefer keeping the head and body separate, but this is one of those areas where you can explore your own workflow. I'm going to follow the exact same procedure in Faceform that we used for the head. I duplicated all the nodes we created earlier and imported the respective meshes along with their textures. Make sure to align the body first. Once the alignment looks right, I go into the visual editor and begin adding the point pairs. There are a lot of points to add for a full body, especially if you want it to wrap accurately, try to be as precise as you can. But again, it does not have to be an exact one-to-one match on the pixel level. If the wrapping shows deformation issues later, you can always come back, remove points and recreate them. However, the important thing is that the one-to-one matching must remain consistent. If you make a mistake halfway through, it becomes extremely hard to track down and fix. So take your time while placing them and frequently check that the point numbers match on both sides. Alright, so once done, I'm going to compute the wrapping. As you can see, we now have a clean, well-wrapped body with almost no refinement needed. I'm switching to Blender now because I noticed a strange issue in Unreal Engine 5.7 where OBJ files do not import with the correct transformations, even if you add the offset transformations in the import settings. Until that bug is resolved, I need to convert both the head and the body back into FBX before bringing them into Unreal. While importing the FBX asset that I exported from Blender, you need to remember that Blender's default scale is typically 100 times larger. So to match the scale of a MetaHuman accurately, I had to set the offset uniform scale to 0.01 here. Now inside my MetaHuman character creator, Under the conform section of the body tab, I choose from template and add the body mesh. There is also an option to add a head mesh, but this does not bring in your custom head. It is only used to align the neck if you already have a head that requires adjustment. Okay, so I'm going to click on this confirm button now. Alright, so the body is now conformed correctly. I will move over to the head section, and under conform, I again choose from template and select our head mesh. If you have custom eye and teeth meshes, you can add them here as well. Alright, so the head is now perfectly conformed and also matches with the body, and the result is giving me goosebumps. This whole pipeline is honestly getting me excited about what is possible in the near future. Just look at how much trouble this caused earlier. When I followed these exact same steps in Unreal Engine 5.6, the head scale was completely off, the proportions didn't match the body, and I had to make countless adjustments just to get everything aligned. It was messy and unpredictable. But in 5.7, the workflow is straightforward. The conformation system and the synchronization between the body and the head is far more reliable. Before making any further adjustments, I will quickly generate the rig because I want to test the issue I experienced earlier in Unreal Engine 5.6, where the custom body mesh caused the rigging to be completely off. With all the different types of head meshes and body meshes, I can create full MetaHumans without ever needing to jump into heavy 3D applications like Maya or Blender for manual refinement. As someone who is not really an artist, that kind of manual sculpting work is something I would prefer to avoid, and this workflow finally makes that possible. So the rigging is finished and I can already see something is off. The hand position is not lining up the way it should. Let me play an animation to double check. Now I can see another issue as well. The hands are flickering. This means the rigging did not generate correctly. I will step back, remove the rig and return to the body conform section so we can fix this properly. Here you will notice a checkbox that says target mesh is in MetaHuman A pose, but our mesh does not follow the exact MetaHuman A pose. The hand positions are slightly different, so we need to turn this option off and run the conform process again. I will create the rig once more and see if this resolves the issue. This looks perfect. The rigging is completely accurate this time, no further glitches I can find, and this is the major improvement of the body conformation in Unreal 5.7 as compared to Unreal 5.6, because previously it was almost impossible to get the rig working correctly without some additional adjustments in some custom plugins inside Maya. Alright, so let's remove this rig. So now we can start customizing this further. The face texture you see right now is the default one, and we are going to replace it with the custom texture that we exported from Faceform and refined in Photoshop. If you take this into a tool like Substance Painter and spend some extra time refining it, you can push the visual quality even higher. In one of my upcoming videos, when I cover more of this pipeline in depth, I will definitely go into that part as well. Okay, so now that our MetaHuman is fully rigged and working correctly, it is time to assemble it. Assembling will basically export the character in a ready to use form. Before that, I need to download the texture source from here. Once the source textures are downloaded, you will notice that the custom face texture looks messed up again. That is fine. We will leave it as it is for now because we will replace the correct texture later through the material instance. I have added the assembled character into the viewport, and now I want to tweak the material to bring back our custom texture. Inside the material instance, you will see a boolean variable called useVirtualTexture, which is currently enabled. In simple terms, virtual textures are an optimized way for Unreal to stream and handle large textures more efficiently. In the base color baked VT parameter, I will add our texture. But as you can see, it did not work. The face turned completely black. That is because our texture is not a virtual texture yet. If you want to use the texture as it is, you can disable the virtual texture option and it will work immediately. But I want to continue using virtual textures for better performance. So I will right click on the texture and choose convert to virtual texture. You will not see the change update instantly because the material does not refresh virtual textures in real time. So I'll just reset it and add the texture again. Now you can see that the correct texture is being applied. Now let us create some AI generated textures from this. I took the base texture map into ChatGPT and asked it to modify the map according to my requirements. After a few iterations, it produced something I really liked. I also tested the same process in Gemini and you can see how impressive these custom textures look. This one here is the Gemini generated texture. Now this already looks fantastic. And the best part is that no manual texture painting was needed. It already has a polished, stylized feel right out of the model. And this one is generated by GPT. I personally like this one even more because of its minimalistic design. By adjusting various parameters in the material instance, I can easily fine-tune the colors and other properties to get exactly the look I want. Similarly, you can adjust the texture for the body as well. Here I am not going to spend too much time on the body texture because this is just the repetitive process that I already showed you for generating the face texture. You can also notice that the face and the body do not match perfectly around the neck area, simply because they come from two separate texture sets. The only way to make them perfectly seamless is to modify both together in a tool like Substance Painter. I will cover up that process in one of my upcoming tutorials. This entire pipeline, from AI generated meshes to Faceform to MetaHuman, opens up a huge range of possibilities. The amount of customization you can achieve without ever going deep into traditional 3D sculpting is incredible. I will continue exploring this workflow, refining it, and pushing it further in the next videos. This project is also available on my Patreon, so if you want to explore it further or support my work, consider becoming a member. The link is provided in the description. So thanks for watching, and as usual, don't forget to like, share and subscribe for more such tutorials like this one. I will see you in the next video.